Good morning. My name is Mr. Taylor. I'm one of the assistant head teachers at Kelvin Hall School, and my role is I'm the director of mathematics. So as you could probably guess, today's lesson or this morning's lesson is going to be based upon maths. But it's not just going to be a normal maths lesson. We're going to look at the history of mathematics, and we're going to look at certain influential, famous mathematicians that have had a huge impact, right, on the world. So, first little activity. Okay, I'm going to put up 4 pictures of mathematicians. Okay, quite famous mathematicians. Now, I'm not expecting you to get all 4 of them by any means. You might get 1, you might get 2, right? But try your best. Okay, so I'm going to put up 4 pictures, and there's also a clue next to the picture as well, right, to help you identify who they are. Okay, so I'll put the 4 pictures up. So there's the first one, second one, third one, and the final one. So if your teacher could pause the video now to give you enough time to talk it through in your pairs to see if you can identify the famous mathematicians. Best of luck. Right then, let's see, how did we get on? So the first one, top left-hand corner, probably the most obvious of the 4, I would think, is Albert Einstein. Now, Albert Einstein was a German mathematician and also a physicist. He developed the general theory of relativity, which is the foundation of much of our scientific understanding of the universe that we live in. In 1921, he was awarded the Nobel Prize in Physics, and he is famous for the equation that you see there, E equals mc squared. In the top right-hand corner, we have the British mathematician and computer scientist, Alan Turing. Now, he's widely considered to be the father of theoretical computer science and artificial intelligence. And it was during the Second World War that he worked at Britain's code-breaking centre at Bletchley Park. And you might have seen a film that's been based on his work there. Now, he's really famous for helping decipher the German messages that allowed the Allies to win several battles in the Second World War and then win the war overall. In the bottom left-hand corner, we have Ada Lovelace, and she was daughter to Lord and Lady Byron. And Lord Byron is an extremely famous poet, right? She described an algorithm for the analytical engine, which is the first real computer to compute Bernoulli's numbers. Now, this is considered to be the first algorithm specifically tailored to be used for a computer. And she's widely known as the first computer programmer. So if you think about all the things, right, that are using coding to help programs such as computers, mobile phones, tablets, right, games consoles, she started that. And so it had a huge impact on our world. Now, the 4th person, I didn't know much about myself, right, until I watched a film a few weeks ago. And this person is called Srinivasa Ramanujan. And this person is what the rest of the lesson is all about. So, the man who knew infinity. In 1887, in the temple town of Arodh in southern India, a clerk working at a sari shop and a housewife who sang at the local temple celebrated the birth of their son, Srinivasa Ramanujan. In 1892, at the age of 4, Ramanujan started school. He didn't like school at first, and he often tried to truant. His parents had to get the police involved to make sure that he attended. As he grew older, Ramanujan started to enjoy school more. At the age of 10, so just ever so slightly younger than yourselves, he passed all of his primary exams, coming first in his district. Ramanujan was also really close to his mother. Now, she was a very religious person, and from her, he learned all about Hindu culture and their traditions. By the age of 11, Ramanujan had started secondary school and had already started to work on mathematics beyond that of college-age students. Finding that he wanted to learn more than he could at school, Ramanujan studied mathematics at home. At the age of 13, he was coming up with mathematical theorems of his own. Now, Ramanujan was from a very poor family who would not have been able to send him to college. However, in 1904, at the age of just 17, he won a scholarship to go to a local college. The problem was, though, he was only interested in maths, and he couldn't be bothered studying any of the other subjects. So, inevitably, in the end, he failed all of his other courses and he was thrown out of college. Ramanujan decided to continue his studies independently, earning respect from fellow mathematicians that he met. At this time, though, he lived in extreme poverty, often close to starvation. In 1912, Ramanujan managed to obtain work as an accounting clerk at the Madras Port Trust. He completed his work quickly, allowing him to spend the rest of his time on his mathematical research. In 1913, mathematician friends of Ramanujan started trying to present his work to British mathematicians. Initially, no one was really interested, but Ramanujan didn't give up. Determined to have his work recognised, he wrote to the mathematician G.H. Hardy, who was based at Cambridge University in England. Now, Hardy recognised that Ramanujan was a mathematical genius. He was keen for him to come to Cambridge to continue his research. Initially, Ramanujan resisted, but apparently one day his mother had a dream in which a Hindu goddess told her to stand no longer between her son and the fulfillment of his life's purpose. In 1914, Ramanujan set sail for England, arriving a full 28 days later. At a time when it was unusual for people without money to even attend university, he received a full scholarship from Cambridge, covering not only all of his costs, but it was also sufficient as well to support his family back home in India. At Cambridge, Ramanujan continued to impress Hardy and all of the other professors of mathematics with his incredible ability to spot mathematical relationships and develop mathematical theories. Only 2 years after arriving in Cambridge, he was awarded a PhD. Now, you've got to remember at this time, this was all happening during World War I. Ramanujan's health also started to fail at this time, and he decided to return to India in 1919. However, he was to die just a year later from illness. Ramanujan came from extreme poverty, but because he believed in himself and because he believed in what he was capable of, right, he was able to do extraordinary things. Much of his research, right, he did completely independently, and he never, ever gave up, despite all of the many rejections and the setbacks that he had through his life. Hardy compared him to Euler, who was recognized by many as the greatest mathematician to have ever lived. Ramanujan developed almost 4,000 mathematical theories, including a way to calculate pi, and he also came up with clever puzzles such as the Ramanujan square. And we're going to look at this square, this magic square, in a bit more detail later on. Now, if you look carefully, right, you can see that each row, each column, each diagonal all add up to the same total. Now, his mathematical theories have influenced physicists in their study of matter. An example of this is trying to understand how black holes operate within space. As I mentioned earlier, right, Ramanujan, right, came to my mind from a film that I watched just recently, just a few weeks ago, right? And it's called The Man Who Knew Infinity. And it helped inspire me, right? It gave me an insight to look back at all the history from different mathematicians, and I hope it's going to inspire you as well, right, for you to do your best, because you never know, right, in the room that you're in, right, you yourself or the person, people sitting near you, right, could be an Olympic champion. We might have the next Alan Sugar, brilliant entrepreneur, right, or we might have someone who finds a cure for cancer. Now, I believe that Ramanujan is a perfect example of no matter what your background is, right, you can achieve if you work hard and you believe in yourself. So let's watch the trailer and see if it inspires you as much as it inspired me. I hope you enjoy it.
What do you see? fan?
Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything.
Integrals, infinite series.
I've never seen anything like that. From an Indian clerk, ill-educated in Madras, I would very highly value any advice you give me.
Letter for you. It's not English.
Yours truly, S. Ramanujan.
What does the S stand for?
Not himself.
We intend to invite him here.
Don't forget me.
I could never.
Are you Ramanujan by chance? Oh, don't be intimidated. Great knowledge comes from the humblest of origins.
For the good of everybody, you should attend some lectures.
I'm here to publish. The letter only contained a small sampling of my discoveries.
This will take a lifetime.
Maybe two.
We need proofs of your work.
But they are right, sir.
I hadn't completed that proof. How do you know?
I just do.
You don't pull a stunt like that in my class.
Now get out!
How do you know that theorem?
It came to me. These steps you want, I do not know how to do.
Where do you think you're going? This is our home.
Don't you know what I've given up to be here? I have nothing. You wanted to know how I get my ideas. God speaks to me.
There are no proofs. We're just supposed to take him at his word.
No, you're to take him at mine. Why do you do it?
Because I have to.
There are no proofs that can determine the outcome in matters of the heart. We are merely explorers of infinity in the pursuit of absolute perfection.
I owe you so much.
No. It's I who owe you.
So that was the trailer for The Man Who Knew Infinity. And if you enjoyed the trailer, please do go and see the film. Right, it is brilliant, like I've already said. Now, we've been a lot of me talking within this one, okay? So I want you, right, to do some work now, and I want you to use your superpower, that Mrs. Andrews was talking to you in the previous math lesson. And I want to see if you can create your very own magic Ramanujan square. And I believe every single person in this room can do it. So I've got another little video for you to watch, and then at the end of the video, if you can have a go at creating your own, that would be absolutely brilliant. Yeah, so here we go. Sorry about that. 2 seconds. Try and get it back to the right place. So there you go, right? See if you can be successful using that formula there to do your Ramanujan square. So I hope you've enjoyed the lesson, and I hope you be successful with your magic squares. And please, next year, guys, right, I'd love if you could show me some of the squares that you've done within this session. All right. Best of luck then. Goodbye.